Hello everyone, I am Vijay Katta and this is my second lecture on the error control ARQ. In the first lecture, we focus on the flow control and the error control techniques. So let's start with the error control ARQ technique. ARQ stands for automatic repeat request. This is nothing but the retransmission concept. So for the error control ARQ techniques, there are two techniques broadly discussed. One is called as the stop and wait ARQ, and second one is the sliding window ARQ. So sliding window ARQ techniques again are divided into go back and selective reject or selective repeat technique. But we consider one more technique here, or that is called as a one bit sliding window ARQ technique. So in the stop and wait technique, we said one frame at a time and wait for the acknowledgement. If positive acknowledgement comes, then we will send next packet. If negative acknowledgement comes, then we will retransfer the same frame. In sliding window protocols, rather than sending one frame at a time, we will send a bunch of frames at a time. Now, this bunch of frames means the number of the frames is decided from the receiver's end, the capacity of the receiver. Now, one bit sliding window protocol is similar to your stop and wait protocol. Here, window size is of only one bit, so we can transfer a one bit frame sequence here. Now, let's start with the stop and wait ARQ technique again. So, in the stop and wait technique, under the normal conditions, whenever the frame has been transferred, immediately timer has been started by the sender machine. So sender has transferred frame number 0 to the receiver here. Now after receiving this frame, it will check the error detection technique through error detection technique, like for example CRC. If frame is okay, then receiver will send ACK1. ACK stands for acknowledgement, 1 stands for what represent that receiver is waiting for frame number 1. So the combined ACK1, the combined meaning of ACK1 is receiver has received frame number 0 and he is waiting for frame number 1. So after receiving the acknowledgement within the timer, uh, next, again, frame F1 has been set and timer has been started. So, after receiving F1 frame, receiver will process it and then transfer ACK0, means frame number 1 has been received and 0 represents now he is waiting for frame number 0. Basically, in the stop and wait protocol, generally only two sequence number are used, like a 0 and 1, but in some books they mention 1 2 3 4 sequence number also there. So if we follow 1 2 3 4, then in the current diagram, the for the acknowledgement number for respective one will be ACK2. So you can follow any technique to represent the stop and wait protocol. Now these are the few conditions where ARQ techniques work. So now stop and wait ARQ technique under the lost data frame. Sender has sent the data frame 0 and timer is on. But a timer, this frame has been lost. It is not received by the receiver. So receiver will not send any acknowledgement. So when timer will be off, sender will retransfer this frame data 0. Again timer will on and it will wait for the acknowledgement. Now if this packet has been received, then acknowledgement 1 will be transferred by the receiver to the sender machine. So this is a concept where ARQ automatic repeat technique works. So it means ARQ techniques works along with the concept of the timer. So all our ARQ techniques that we are going to discuss are work with the timer. So this time period is decided on the basis of time required for transmission of frame, time required to process the frame at receiver end, and time required for transmission of the acknowledgement. So according to this concept, this timer has been implemented. We will take another condition. In the next condition is stop and wait ARQ technique. Now acknowledgement has been lost. Suppose sender has sent data frame 0 and it has started the timer. Now this 0 frame has been received by the receiver and he has sent the positive acknowledgement, that is the ACK1. It means frame 0 has been received and waiting for frame number 1. But this acknowledgement is lost due to the noisy behavior of the channel. Then again, sender will wait for the acknowledgement till timer is in. As timer is out, means timer is completed, again that same frame will be transferred to the receiver. Now when receiver will receive this frame, he will again transfer the acknowledgement to one sequence, and he will discard the last frame. So along with the sequence number, receiver can identify which is a duplicate frame or not. So this is a concept where ARQ technique is used for the loss frame detection. Now next one, here we have discussed the lost acknowledgement. Now third condition in the stop and wait protocol is that is called as the ARQ with a damage frame. So sender has sent data frame 0 to the receiver. Receiver has processed this frame, sent the acknowledgement ACK1. Then next condition, data 1 has been transferred. Receiver has sent acknowledgement 2. This is a positive acknowledgement. Now sender has sent third frame whose number is data 2 to the receiver. Now some error has been occurred during the transmission phase, and receiver has detected with the help of, for example, CRC technique. So it will send a negative acknowledgement NAC frame to the sender. Now in the stop and wait protocol, there is no need to mention the sequence number here, because we are sending only one frame at a time and waiting for the acknowledgement one. So we can send NAC frame. When NAC frame will be received, sender will identify that that data 2 has been corrupted and he will retransmission. So this is an automatic repeat request technique where receiver received the correct frame at the end of the communication. So in this way, we implement the stop and wait protocol. Again, I summarize the thing. Stop and wait protocol transfer one frame at a time and wait for the acknowledgement. If acknowledgement comes within the expiry of the clock, then next frame will be transferred. Otherwise, the same frame will be retransfer that. And this retransfer concept is called as the ARQ concept. Now, the advantage of stop and wait protocol is it is a simple technique, and disadvantage of this technique is a wastage of bandwidth. Now, to overcome on the concept of the wastage of bandwidth, we have implemented another ARQ technique for error control, that is called as the sliding window protocol. So as we discussed in the last lecture, sliding window protocol, in the sliding window protocol, rather than transferring a single frame and waiting for the acknowledgement of that frame, we transfer a bunch of frames here. Now window is called as the logical concept. It represents now window has a logical edges. Let's say this is the left hand side and this is the right hand side of edges. The frames within this window are called as the frame that are currently transferred by the sender. So here the window, this imaginary box or window, can shrink and grow. So consider again a sender side window. So in the sender side window, the left hand side of the wall is moved in the direction whenever sender send the frame. So currently there are total 7 frames, window size is there. When sender will send 0, now the when sender will send this 0 frame, window size will be like this one: 1 2 3 4 5 6 7. When it will send suppose frame number 2 in the particular sequence, then window size will be 2 3 4 5 6, like this one. So the left hand side, from the left hand side, window is shrink that one. Now when receiver will send the acknowledgement, suppose it has sent the acknowledgement for 3 frames, that is frame number 0, frame number 1, frame number 2, then our window will be increased by the same size. That is a new frame 701 will be inserted into the logical box. So this concept is implemented at the sender end. Now we will study at the what happened at the receiver end. So on the receiver side, again this is a window, original window as defined here. So whenever receiver will receive a frame from the sender, the window will shrink in this direction. And suppose receiver has received 2 frames, that is a 0 number and 1 number from the sender, then the window size will be 2, 3, 4, 5, 6. Now this maximum window size is defined accordance with the buffer capacity and processing capacity of the receiver. Now next one, whenever the receiver will send acknowledgement, so suppose it has sent the acknowledgement for two frames, that is a frame number 0 and frame number 1, immediately our window size will be increased by 2. So like this one, window shrink and expand at the both receiver and sender end. So I have explained the concept of stop and wait ARQ technique. Now we will focus on the sliding window technique. And again, in the last few slides, we mainly study the concept of sliding window. Now we will focus on the go back and selective reject or selective repeat ARQ technique. So first one, we will start with the go back and technique and represent the sequence number of the particular frame. Now, in this diagram, this is the sender side. This particular upper portion represents the sender side, and the bottom portion of this figure represent the receiver side of the frame. Now, sender has sent frame number 1. It is correctly received. It has sent again frame number 2. It has sent frame number 3. It has sent frame number 4, 5, 6, 7. So complete window, for example, all 7 frames has been sent by the sender and receiver has not sent any acknowledgement. So in the go back and protocol, now when complete frames in the window has been sent, receiver will be in the waiting condition. Now meanwhile, suppose frame number 1 has been processed, frame number 2 has been processed and they are correct, and now they have received the frame number. There is error in frame number 3 is occurred here. So as receiver will identify it, there is a problem in frame number 3, it will send an acknowledgement called as a NAK3 acknowledgement. Now here in the sliding window protocol, we will use the sequence number along with the negative frame. In stop and wait protocol, we have not used the sequence number, but in the sliding window, we will use the sequence number. So immediately when receiver will receive this, sender will receive the frame NAC3, it will retransfer all frames from frame number 3, frame number 4, frame number 5, frame number 6, and frame number 7. While at the receiver end, if error is occurred at frame number 3, then all remaining frames that has been received by the receiver will be discarded. So if error occurs in the initial frame, then all buffered frame will be discarded. Now this is the biggest drawback of the go back and technique, and that's why this technique is called as a go back and. For the current example, this is called as a go back 3. Although frame number 4, 5, 6, 7 has been received, and I assume it is received correctly, but due to the protocols technique or due to the protocols behavior, all these frame will be discarded only for the single frame that is called, in which error has been occurred. Now after when sender will again send frame number 3, then frame number 4, 5, 6, 7, and then same mechanism will be followed. If all frames are correct, then receiver will send the acknowledgement for the remaining frames. So this is a technique called as a go back and ARQ technique. Now we will consider some issues that observed in go back and ARQ protocol. First is called as the lost data frame. So sender has sent first data frame 0. Receiver has not given any acknowledgement. Sender has sent data 1. Sender has sent data 2. Now this data 2 has not been received by the receiver due to network issue, and it is again it sent a data 3. It is received by the receiver. Now as this sequence number data 3 will be received here, immediately receiver will discard it. Then suppose a data frame 4 has been also received. So 3 and 4 has been received and 2 has not been received by the receiver. Immediately frame number 3 and frame number 4 will be discarded because the sequence number 2 is absent. And negative acknowledgement 2, NAC2 will be transferred to sender. Now when NAC2 will be received by sender, he will observe that he has sent frame number 0, 1, 2, 3, and 4. And this negative 2 acknowledgement represent frame number 0 and frame number 1 has been successfully received, and there is only problem in frame number 2. So it will transfer all frame after frame number 2, that is data frame 2, data frame 3, data frame 4. It means negative acknowledgement has two meaning. First one, suppose take the example NAK2. NAK2 means frame number 0 and 1 has been successfully received, and there is a problem in frame number 2. Now take another example. Suppose sender has received NAK5. This is the first acknowledgement received from the receiver. It means frame number 0, 1, 2, 3, 4 has been successfully received and processed, while frame number 5 there is an error. So for the lost data frame, we send a negative acknowledgement. Now take another example. Here, go back N ARQ along with the damaged data frame. Means frame has been received, but it is corrupted. So sender has sent 0, 1, 2, 3, 4 frames here. Total 5 frames has been sent. But at receiver end, when receiver process frame number 2, that is a data 2 here, it observed that that frame has been corrupted due to network issue. So it will send NAC2. NAC2 again, it means frame number 0 and frame number 1 has been correctly accepted, and there is an issue in frame number 2. So again, the frames after frame number 2, that is frame number 2, 3 and 4, all frames will be discarded by the receiver, and sender will again send data frame 2, data frame 3 and data frame 4. So in this fashion, go back and protocol ARQ works for damaged data frame. Now there is again another possibility called as the lost acknowledgement frame concept. Now suppose whenever the sender send the data, again timer concept is here, timer is implemented. So data 0 is sent, data 1 is sent. Now he has sent the acknowledgement for the frame number till frame number 1. So the ACK2 means frame number 0 and 1 has been successfully received, but this acknowledgement has been lost. Now till timer is not out, sender will wait for the acknowledgement. After the timer is out, sender will again retransfer frame number 0 and frame number 1. So when this frame 0 and 1 will be received by the receiver, he will identify that, or he will assume that his acknowledgement frame has been lost. So in this fashion, go back and sliding window protocol works. Now again, there is an issue here in the go back and protocol is that although this frame number in the particular diagram, frame number 4, 5, 6, 7, which has been successfully received, but they are discarded due to there was an error in the frame number 3. So for a single frame, n number of frames can be discarded in the go back and protocol. Now to remove this drawback, there is another protocol called as a selective repeat or selective reject ARQ technique has been implemented. Now in this technique, only particular frame in which error has been occurred. Now again, this is a sender window, this is a receiver one. Sender has sent frame number 1, frame number 2, frame number 3 here, and frame number 4, frame number 5, frame number 6. Suppose it has been received here. So suppose there is an error in a frame number 3. So receiver will buffer frame number 4, 5, 6, 7. It will not process this frame till sender will not retransfer frame number 3. It means in the selective repeat concept, frame will be processed in a sequential order. The higher order frames like frame number 4, 5, 6 will be in the buffered. It will not process. When frame number 3 will come, we will process the frame number 4, 5, 6, 7 in this pattern. So here no frame has been, here only errored frame has been discarded, remaining frames has been buffered. So this technique provides a high throughput as compared to go back and techniques. So in the next lecture, we will study the protocol efficiency. Thank you.